Hello students, with respect to the projection of planes as we have discussed in a previous video where we can locate the points which are located in different quadrants. We have one more problem here, so we can just go with that just to have a reference. So whenever you find such a problem, you can just drop X file, okay, that is plus marks, and we can write HP, VP, okay, and you can just need not to write all these things. You can just look into the problem, what exactly it says. What it says, name the quadrant. So there is a point E which is 30 mm below HP and 25 mm behind VP, below and behind. Okay, so you can say below HP is somewhere here in this quadrant, and behind VP it will come in the third quadrant. In the third quadrant, the front view will be below XY line and the top view will be above XY line. So easily you can locate in that way. There's a one, and there's a one more EF 35 mm below and 30 mm in front below. First you just locate anyone. Below HP means these two quadrants, and in front means obviously it's a fourth quadrant. And in the fourth quadrant, as we already know, okay, so both the views will come below the XY line. Okay, this is the second one, and one more is on HP and 30 mm in front of VP. Okay, so on HP means on this line. Okay, in front of VP means either it will come in a third or it will come in a fourth position, because it is exactly on the HP. So it can belongs to the first also, or it can belongs to the fourth quadrant also. Okay, so we can say it located in first as well as in the fourth quadrant. And there is a point H on HP 30 mm behind VP. So on HP again on the horizontal line, and behind means either in the second or a third quadrant. So we can say it lies either in the second or a fourth quadrant. Means whenever you get a such a problem, okay, so in order to locate it in a which quadrant it lies, okay, so one simple way is you can just drop uh, sorry, this is too high, so we can just drop a two lines, okay, and you can say in a random way, so this is VP and this is VP, this is HP, this is HP, and you can just look at here. So this is the first, this is a second, this is a third, and this is a fourth. Okay, and whatever the problem they are going to tell, like it is below and behind. You can say below, okay, and behind. So in the third position, third quadrant. Okay, you can just locate in this way, like if it is in the third quadrant. So this uh, okay, so when we rotate this HP 90 degree, so it will be moved up in this way. Okay, that is front view will remain here, the top view is moved up. So like that we can easily locate in which quadrant it is, and we can drop the projections. Okay, so that's how exactly we can go with the projection of points. And there's a one more, so where they say one simple problem, and then we'll move on to how to locate the side view of a point. It's one simple, yes. There's a point, a P, which is 30 mm in front of VP and 40 mm above HP. Above HP means here, either in the first or a second quadrant, and in front means it is in the first quadrant. Okay, so the point lies in the first quadrant, and we can just drop with that one. And with respect to the side view, we'll see now how we can draw that. So in order to uh, draw that, what are the problems? So what we do normally here is So we'll take a reference that is that intersection point, not as a VPHP. So we'll take this as X and this as a Y, and this as X dash and this as a Y dash. Okay. So now with respect to the which quadrant it is, we can see here the point P is 30 mm in front of VP and 40 mm above HP. That means that it is located in the first quadrant and the front view will come above the XY line and the top view will come below the XY line. So the front view is with respect to above. So it is 40 mm above HP. So we can say, so we'll take it from here, one line, a thin line, okay, and it is 40, enter, 90, enter. Okay, so then it is 30 mm in front of VP. In front of VP means that will come in a top view. So on the same line, we will take 30 mm down. Okay, so now to locate the point, normally we take it as 2 mm, one at this end and one at this end. Okay, so this is the front view, so it's a P dash, and this is the top view. We'll write P, and that's a top view, and P dash, that's a front view. Okay, so go with the smart dimension where we can say this is 40, this is 30. Okay, we are keeping this x dash y dash to the right side because they have mentioned some distance with respect to the RPP. RPP means right profile plane. So this now we are referring it as a right profile plane. So we can say, so this one is RPP, and they have told the dimensions are 50 millimeter from the plane. So what we can do here is, I will take a line from here and I will say this is 50. Keep all the lines here and 1 3 only, and we need to move this line till here. Okay, now again smart dimension, this distance is 50, so it is 50 millimeter from the RPP. And remember one thing, so the side view always appears in line with the front view. Okay, that means we have already a line, so the side view will appear on this line. Okay, in order to locate the side view, we need to have a line which is of 45 degree from the intersection of this one. Okay, x dash and y dash, we need to have a 45 degree. Let me just give minus 45 degree and let's drop a line here. Okay, so now from the top view we need to have one horizontal line which intersects with this 45 degree line, and once it intersects you need to move it up, and wherever they intersect you just go to the trim of this line. Okay. So the side view of that line will appear at this point. This one is our P double dash, that is we write LSV, that's the left side view. We are viewing from here and it is appearing on the RPP. So now go to the angle between, this is 45 degree. That's how exactly we can drop the projection of a point. Okay, so remember one thing, okay, the side view will always appear in line with the front view, and there is always a 45 degree line in front of the top view. Okay, and once you project it, so easily you can locate the side view of the point. So that's how exactly we can solve this problem where we say a point P is 30 mm in front of VP It's a top view, 40 mm AOHP front view, and 50 millimeter from the RPP. Plus 50 millimeter from the RPP.